Uranus was husband of Gaia and father of Rhea, Iapetus and Tethys. He was a god of the sky and the father of Titans. Neptune was the god of the water and the sea, and husband of Cilicia, the goddess of salt water. He was Neptunus Equester, the patron of horses. Together, of course, they are the ice giant planets of our solar system. Hi everyone, Vega here, and in today's video we're going to be looking at Uranus and Neptune in a battle of the ice giants. So, let's get to it. First of all, imagine looking on a scene like this, the beautiful rings of Uranus. Although formally discovered in 1977, Uranus's rings were reported as early as 1789 by William Herschel. The system itself contains 13 rings and several shepherd moons. Here we can see a view from Miranda, the closest into Uranus of the larger moons is 129,000 kilometers. In the distance, the Sun at magnitude -20 moves above Uranus's swirling clouds. What a wonder. Or perhaps we might prefer a descent through Neptune's clouds, the swirling winds in a great dark spot. The Sun is now dimmer, of course, than the full moon on Earth at a meagre 12 magnitudes. A huge spinning storm with the winds of up to 2,100 kilometers per hour or 1,300 miles per hour. The original great dark spot was the size of Earth and is thought to be a hole in the methane layer of the planet. How about meeting the families of the two giant planets? Well, let's have a look. First of all, and probably the most prominent of all, is Triton. At 1,353 kilometers of radius, it's the 7th largest moon in the solar system. Next, we have at 8th Titania, but somewhat smaller at only 788 kilometers. Next, Oberon and Umbriel, the 10th and 13th largest moons in the solar system, 761 and 584. And interestingly, we carry on in the Uranian system with Ariel and Miranda, 14th and 19th respectively in the ranking. So, interesting, isn't it? Because although Neptune has the largest moon, its next largest moon is only the 21st largest in the solar system at 210 kilometers of radius. Proteus barely even resembles a ball, and Nereid indeed the 3rd largest moon of Neptune, 23rd on the list. We can see that the two worlds almost equally matched. In the future, of course, we'll no doubt colonise the ice giants. How about the nitrogen geysers on Triton? Here we see one of the first outposts, and on Triton itself, argues to be the most habitable body of the two ice giant families. Triton has enough atmosphere to enable small grains to be blown in the wind, as geysers erupt with sublimating nitrogen gas, as we can see here depicted. A full atmosphere, unfortunately, is probably never likely to happen, but Triton, along with Titania, is perhaps our best bet for permanent habitation and at least some resemblance of atmosphere. How about the view from Umbriel, looking at the winter side of on its side now Uranus, with its ring system seen from a top-down view? We can see them passing over the 5 of the 6 inner planets of the solar system: Saturn, Jupiter on the outskirts, and later Mars. Here we can see on the right-hand side of the Sun, and of course our own Earth and Venus. Interestingly, Mercury still cannot be seen because of the glare of our Sun, but also curiously is the closest planet to Uranus on average. In fact, Mercury is the closest planet to all the other planets on average. Quite a curious fact, isn't it? How about reaching the two giant worlds? Based on current technologies, the logistics are very difficult. As we know, as things stand, only Voyager 2 has reached the two ice giant planets. And on current technologies, a flyby to Uranus, for example, would take up to 9 years, and Neptune, the more distant of the two, 12 years to travel the 3 billion kilometers distance. And that's just a flyby. If we actually wanted an orbital insertion, which is more difficult and taxing manoeuvre, that would take roughly 16 years to approach Uranus and set in its orbit, whereas Neptune, the more distant of the two, could take even as many as 21 years depending on where it was, and of course we always depend on other planets to make the gravitational assists in the journey. So neither planet is going to be visited in the next few decades. However, let's look to the future now, because at some point we're going to have to colonise this solar system of ours, and we're going to have to build and create better drives. Let's imagine for now that we could travel at 0.01% of light speed, which is approximately 10,800,000 kilometers an hour. Super fast for us, but how would that change transit times between the worlds? Let's have a look. Neptune to Earth, of course, at 29 astronomical units at that speed would take 16.8 days of transit time, whereas Uranus to Earth at only 18 astronomical units is 10 days, so not an unreasonable distance, but again this is at 0.01% of light speed. How about a transit between Neptune and Jupiter? If we've colonised the solar system, we will be transiting between the two, obviously. And at 25 astronomical units between Neptune and Jupiter, it takes 14.4 days, or 8.1 days to travel the 14 astronomical units between Uranus and Jupiter. Now we know that the Galilean moons could be prime real estate for habitation, so that's quite a likely journey. How about Neptune to Mars or Uranus to Mars? Well, as we can see there, 16.4 days from Neptune and 10.4 from Uranus. And also Neptune to the small dwarf world of Pluto. Pluto may not seem like a likely destination, but with its other bodies like Charon and Nix and Styx, it may well become a very developed place in future times. And here we can see Neptune to Pluto, of course, at the minimum distance is only 10 astronomical units, or 5.8 days. That, of course, would depend hugely on where Pluto and Neptune were in the sky, as it could extend to almost 50 or 60 astronomical units if they were on the other side of the Sun. Uranus is the same, at 20 astronomical units from Pluto, would take 11.5 days, so they are relatively close as long as the bodies are lined up. And finally, Neptune to the beautiful planet of our solar system, Saturn, and perhaps more importantly its moon Titan, likely the second or third destination for humanity after we've explored Mars fully, and perhaps the Galilean moons. Well, that would take 11.8 days from Neptune and 5.6 days from Uranus. So, it is possible, but we're going to have to invent new drives and technologies to get there. So, in summary, we've had a battle between Neptune and Uranus, and you might be wondering who wins. Well, for me it's a toss-up. The two bodies, as we know, are very similar in mass and size. Also, we've seen the moon systems are very similar as well. But for me, and this is only for me, and if you disagree you can always argue down below, for me the Titan of the two is the blue planet itself, Neptune. This is because I believe it is the more beautiful of the two, and finally, on a personal note, it reminds me of our own blue world, without doubt the most beautiful planet of all of our solar system. Thanks for watching. Don't forget, if you've enjoyed the video, forget to add a like and a share if you can, and you may enjoy one of our other videos on solar system exploration, or perhaps our brightest star series where we look closely at stars like Arcturus and Capella or Vega. Or perhaps you'd like a journey to the second and third largest moons of Saturn, Rhea and Iapetus, or maybe to Triton itself, where we talk about where exactly it came from. Anyway, thanks for watching, and I'll see you on the next one.